Good morning, everyone. Someone is not here yet. Uh, Farrell, is it?
Oh yeah.
Yeah. Mm, I hope he's joining. Today is the last area of the whole syllabus, the last part, actually. Should we wait for him or how? It's not much. It's only about 15 slides left for me to cover. You can see it from your notes. It's not a lot left, just a few bits of areas, which is the correlation coefficient. And also, we're going to look at the Spearman correlation coefficient. So it is going to be, um, I don't know whether we use the whole 2 hours for this 15 slides only. We'll see how our progress is. Yeah. Um, hmm. Should we wait for him or how? Is he joining?
I don't know.
Not sure then, because it's a Monday and it was a long weekend. Did you have classes on Friday?
Got a song, but didn't attend.
Sorry. And you had classes or not?
Yeah, got a song, but we didn't
Oh,
attend because we thought it's a holiday.
oh, there's the class still on.
Yeah.
Did you join the class?
No.
Oh, I see. Because it's supposed to be a public holiday. Yeah. Maybe some lecturers they decide to go ahead with the classes, so it's depending on the lecturers as well.
Because the lecturer is from KL, so KL don't have
Oh,
the holiday.
public holiday. Yeah,
Right.
exactly. Yeah. I also have class on Friday, but I mean my class normally is scheduled on Friday, but uh I do a replacement lah, which means this Friday my class will be whole day with them. So hopefully they won't get too tired. It's the diploma students. All right. So what time already? It's almost 95 minutes. Farrell is not here yet. Did you know that UMS, the campus, has been open for quite a while now, few weeks already? And
I don't.
apparently, what happened? Some of the college Kediaman, it's now PKPD, isn't it? Did you know
Yeah.
about that?
No, yeah.
Yes. Yeah, and there's so many students having to have to do the swap. PKPD is the, I mean, it's like MCO. I don't know what is it. Uh, PKPD. I've read it, but what it? Hang on. PKPD means I've read it somewhere, meaning they are locked down lah. Yeah, and it's much more stricter compared to PKPB. PKPB is like RMCO. PKPD is like they cannot go out even. Yeah. And there are three colleges in UMS. And you know, UMS is very near to our campus, but we are not opening yet soon. Expected is in June. Lah. UMS, yes, they still do. They still ongoing currently having classes. Yeah. Yeah, when they go for PKPD, I bet they have to switch to online. But then again, they might, with the condition, they might not have the classes. I don't know what's really going on. That means you can see from the numbers in Sabah, it's, going up each day. It was 60 the other day, then 70. Now, the last I saw was like 80 plus already. Ah, when is this going to end? I'm getting really tired with doing online. And for you guys, especially, it's like a year already, isn't it? You guys have been doing online. What worries me is that when students are so used to doing online, they forgot a face to face method already. But for your course, it's best that you have a face to face because some subjects, especially the networking and the programming, it's best to be face to face rather than online. Maths also basically is good for the good students. I mean, the basic is good, but if you are you need some refreshing course like that, face to face is even better. But then it's all depends on the student, yeah, whether you have the motivation to ask or not. If you keep quiet, it's very hard for the lecturers to know what kind of help do you need. Well, anyhow, yeah, Farrell is a bit late, yeah, so I have to start. Let me. Is there any question you guys wanted to ask? I mean, before
No,
we
no.
start the lecture, no. How about you, Calvin?
Ah, the assignment the assignment. I don't know if the graph. Do I only use graph?
You didn't use graph.
Yeah, I did use graph, but I also wrote down the calculation.
You wrote down the calculation.
Yeah, for the
Oh,
mode,
oh,
the mode. I guess I'm not sure. I'm not sure which one to do. I
oh, you
just
already
do both.
submit, yeah. Already can.
Oh yeah,
Okay. So don't worry about it. I mean, if you did provide both answers, I will of course take the correct one. Yeah. But because I will not penalize students if you answer both. But if you answer only one and it's not answering to the question, then I have no choice lah. Yeah. I mean, it must be according to the question, what the question asks you to do. Yeah. Um, my due date to submit is at 1 today. Hmm. So I guess maybe Farrell is doing that because he hasn't submitted his work to me yet. Not Farrell, Farrer ba, astaga. Yeah, he hasn't submitted his work yet. Okay, I think that was a long time to give you the assignment actually. Can? Well, anyhow, he's not here yet. Hmm. One more year, Kelvin. The MCO, like what online is it? Ayo, very sad.
take very long time to be gone. One
Yeah,
more year, put out the vaccine, and then
yeah.
it's gone.
And then a lot of people not going for the vaccine. And did you know, if you remember the first, not the first, the pandemic that happened before 1920, the 1914 pandemic or 1918, I
Flu, Spanish
think,
flu one.
Spanish flu, yeah. That one, it took like more than 5 years, almost 10 years, I think, to really completely, eradicate that flu. And we're getting it now. Yeah. So, very hard lah, I feel.
I
I,
very
I'm begin I'm beginning to feel the effect of it. I mean, in terms of socially lah, in terms of friends, you seldom see them. When you go out also you feel scared. Do you feel that? No?
used to it already.
You feel it already.
Fair is that.
um Last night I went out for a drive because I was like, I need to go out. I told my husband. So we went out for a drive. And we saw in a lot of shops, like Kedai Makan, I see a lot of young people sitting there very close. I mean, definitely they are from different houses. I mean, different families, yeah. So they come from different houses, and yet they are like socializing, which is good, of course. But now it is kind of dangerous to do it still. But at least our number is not as bad as before. Before it was like in hundreds. Now it's below 100. But when you know that in UMS there is a cluster there now, and then today all the schools, whatever level, they started going back to school. My daughter is included. My youngest is back to school today. So a bit worried. When she's at home, I feel good because, you don't worry. But when they go out and, you know, um, I get worried. Yeah. I prefer if they do online, but my daughter herself, she told me, Mom, I don't think I like online, she said she prefer going to school. But then I think why she likes to go to school is because of her friends. She's so excited. She's supposed to go in the afternoon session, but already she asked my husband to send her early. I don't know. Hey, Farah, you are here. I was just chit chatting nonsense. Yeah. It's okay. Right. So we better start then. Let me present my work. Not my work. Let me present my slide. So I hope everybody is ready. Yes? All
Hi.
okay? Yeah. So let's start. So I share my screen first, and I'm going to record the session now. Good morning. Today is week 12. We are on week 12 and on chapter 7. Today is the 5th of April 2021, and we are completing all the syllabus of BAMS 1613, probability and statistics. So these are the last 15 slides for this semester for this subject. Yeah. So continuing to what we have covered last week, this is under the topic of correlation and regression analysis. We already completed the regression analysis, right? Which we have covered how to construct the mathematical equation of a linear equation involving finding the value of b and then find the value of a, which we can therefore create the estimated formula mathematical equation of the regression analysis. And of course, as what you have covered last week, the regression analysis is very good in order to help us to forecast or predict how much the value of y, the dependent variable, depending on the value of the x, which is the independent variable. And from that mathematical equation, we are also able to know when, let's say, the independent variable is equal to 0, that is, the x is equal to 0, we will be able to predict what is the variable y. I mean, not predict, basically, to know what is the value of the variable y. Yeah. So today is another area. It's called the correlation coefficient, and the symbol we use is R, as you can see here, small letter R. And when we calculate the value of the R, the value that you get should only be between 1 to -1. That means the minimum it can be is -1, and the maximum value is 1. But of course, these values are the strength of the relationship between the two variables. So remember, when we do correlation coefficient, we are checking out what is the strength between the two variables. Yeah. Whatever the variables could be. It could be age and the level of blood pressure of the person. So it can be any area, like the examples that we have done, ice cream and the temperature outside. Yeah. So the thing is, when we do correlation coefficient, we are checking the relationship, the strength of the linear relationship between the two variables. And here, this table you see here is showing to us what is the definition or the interpretation of the value of the R. Meaning, if you get the value of the R as 1, positive 1, yeah, that means it's a perfect, you can see the degree of correlation is a perfect positive linear correlation. If you get a negative 1, it's a perfect negative linear correlation. So all this, yeah, is something that you must remember. We have very high from 0.8 to 1.0 and negative 1 to negative 0.8. Yeah. So all this range of values, we have perfect, very high, high, some. Some can also be known as moderate. Yeah. Moderately. Low, very low, and absent. That means when you get the value of your R equals to 0, it tells us there is no linear relationship between the two variables. So all these you need to remember. Yeah. So it depends on the value of R, what value you get. And if let's say you get 0.7, positive 0.7, that means here we have a high positive linear correlation. If you get negative 0.3, which is here, where my pointer is, that means we have a low negative linear correlation. So it depends on the value of your R after you have calculated it. And this table is rather important. Yeah, you have to remember it. And depends on the question. Yeah, if the question asks you to do interpretation, which is normally the case, or comment on your R, comment on the result that you obtain, then this should be your guideline. Yeah. So whatever your R is, you need to check from this table whether it's positive or negative and identify which degree of correlation it falls into and write the interpretation of the comment correctly. I will show you some examples here. So this is just to show you some examples of the scatter diagram. Yeah, based on the table here, the degree of the correlation, you can see that when your scatter diagram looks like this, without calculating the R, yeah, we already know it's a high positive correlation. Why positive? Because you can see if your X value, let me get my pen first, say your X is here, and compared to the next X, which is here, I mean X-axis, yeah, the value of the X increase, the value of the Y also increase. You notice that? As the X increase, the Y also increase. It shows a positive correlation. As compared to here, this is your X, right? First value, and I take another value of X. You can see here as the X increase, the value of Y decrease. So you see it's going down. Here it's going up. So this part shows a high positive correlation, whereby this kind of diagram show us a high negative correlation. Yeah, so I hope you can visualize it, that when your X increase, but here it's indicating to us that the Y decreases, it's a negative correlation. The next diagram here is showing to us still a positive correlation, because you can see it's somewhat almost like a straight line, but it's the points are scattered more away from the linear form of it. So it's still considered as a positive correlation, but it's not as high as the first diagram. Yeah, same goes with this. It still represent a negative correlation because we still have somewhat like a straight line here, but the points are more scattered away from the linear line. Yeah, so it's still negative correlation, but not as high as what we have in this diagram. Yeah, this one is showing to us no correlation. If you remember, let me go back to the previous slide, that you do get what we call as an absent, or the correlation. The value of your R is 0, and the diagram of it is shown here. This is what we mean by no correlation, because it doesn't form a straight line either. It's just points scattered around. Yeah, so this is indicating to us as no correlation, whereby these, the last one here, is simply showing to us it's forming a curvilinear relationship, which is basically not linear. Yeah, and of course we do not study on the curvilinear relationship. It's a different study altogether. Our focus is more on the linear one. Yeah, like high positive correlation, and the positive correlation or negative correlation, again, it would depend how is it, whether it's a very high, weak, yeah, weak correlation, or simply just a moderate correlation. Okay, so I hope that is clear. In terms of the drawing of the scatter diagram, sketching it, I mean, you will not be asked to do so in the exam. Yeah, it's just for knowledge in this case. Any question for now?
No.
Okay. So therefore, based on the table that I shown to you, and also the few diagrams of scatter diagram, I have example 5 here, of which we're going to start doing the calculation. And you can see this is the formula of the correlation coefficient. And some of the values are what we have calculated last week, like summation of xy, summation of x, summation of y, and also we need to find summation of x squared, and also additional here is summation y squared. So that's why there is a bit of extra. X is your independent variable, y is your dependent variable. You need to find the value of x times y, calculate it. Also, you need to find the value of x squared and then y squared. So all this you need to calculate. And once you get the values, total it, yeah, total each of the values, and then put it into the formula. So first of all, calculate all this, meaning xy is 2 times 9, you get 18. Do the same for the rest. X squared means 2 to the power 2, you get 4. Do the rest as well. And then y squared is 9 to the power 2, which is 81. Yeah. So in here, you need to get all the total of these values. And the total for each one is given here. So if you would double check, yeah, to double check my answer, please. Like summation of x means you just add all these values here. 5 plus 3 plus 4 plus 1 plus 3 plus 2. You should get 18. Summation of y is 9 plus 11 plus 7 plus 13, 11, 15. You should get 66, and so forth for each of the value. Now you might ask, how is it n equals to 6? N is equal to 6 is because we have 6 numbers here. There are 6 rows. Yeah, there are 6 rows here. So let me just write 6 rows. Yeah. So that's how we get our n. Is that clear, class? Any question from anyone?
No.
Okay, so I hope you understand. Farah, you okay? Okay. So from here, we just put all the values in, yeah, and you have to do the calculation, of course. And I don't know whether your calculator will be able to calculate it in one go, but what I do is I normally calculate the top part first, yeah, record it, and then divide. And you can see there are two brackets down here. The first bracket is this, multiply with the second bracket. So I normally calculate it manually. I calculate the first bracket and then calculate the second bracket, multiply them, and then I square it them. And once I got the value on the denominator, then I divide it with or from the numerator. And when you calculate this, please try it out using your calculator as well. You should get 1. So what do you say if it's the value of 1? What does it mean? It's a positive value. That means here, class, we have a perfect positive linear correlation between x and y. Any question?
So perfect means like same like physics.
Yeah.
Oh,
Meaning here, why do we say it's a perfect positive linear correlation between the x and y? Because x and y is not given to us what the variables refer to. So we just write x and y. But why do we say it's a perfect positive linear correlation? Because if you check out with the table here, our answer is 1, isn't it? So that means it's a perfect positive linear correlation. So your answer, the one that you calculated, is based on this table. So that's why here, after we calculated all this, we got the value of 1. This is our interpretation. This is our comment. We say, therefore, R indicates there is a perfect positive linear correlation between X and Y. Is that clear?
nice.
No,
Mhm.
the formula is so long one.
Yes, it is long. Yeah. But yeah, it is long. Before MCO, it's given, I mean, it's given in the formula sheet. Now it's open book. Uh, some question paper in maths, they do give the formula. Yeah, but some question maths paper, they do not give the formula because it's open book. So students, you make sure that you know where to get the formula, of course. And the keyword to know that it is you have to use this formula is to find your correlation coefficient, and you know this is the formula that you have to use. It is a yeah, it is, this is the formula. It is long, there is no shortcut. um I don't know whether, because I myself, I've never used the calculator to calculate a correlation coefficient. I know it's there, but I never check out from the manual how to calculate it, because for this subject here, you need to show the working, right? So that is why I never bothered to check from the calculator, but it is possible. And if you got the time to check how to use the calculator to calculate correlation coefficient, it would be good, because you'll be able to check your answer whether it's correct or not. But by just doing the manual one, like what you see here, finding all the total of x, y, x squared, and y squared, and put all the values into the formula, you will be able to calculate it correctly, without any carelessness lah, of course. And once you get the answer, then you write this comment. And like I said, the comment is based on the answer and from the table that I've shown to you earlier. Yeah. Okay. Any other question from anyone?
And
No. Yeah. Okay. So with that, yeah, this is one example. Let's look at, is this a different example, class? Yeah, it is a different example. So this is example 6, and you can see here, what is our n? What is the value of our n, class?
no, fine.
Yeah, correct. Because we only have 5 rows. So that's what I normally ask students to check out first. What is the value of the n? Yeah. And then you continue by calculating the xy, x squared and y squared, and get all the total for each of the values. And you can see it's very simple to calculate. Yeah. Just to calculate xy, x squared and y squared. But the only thing I notice mistakes that students always make is the process of multiplying it. Yeah, perhaps you're doing it very fast and then accidentally you press wrongly or something. The values will be different, and it will of course affect the total. So all these should be your total for this calculation. And then what you need to do is to put all the values into the formula. Yeah. So what is the value of the R? Is your notes together with the answer?
No.
Yeah. Then can you calculate it and just to make sure you try out how to use the formula and check whether you get the same answer as I do. Okay, I'll give you a few minutes to try it out.
Okay.
Okay. Done? Is it finished? Oh, okay. Let's check it out. So when you put all the values into the formula, you should get oh, Noel. Different Noel. Try and calculate it again. You should get 0.7906. Did I got it wrong? Oh, okay. Yeah, yeah. 0.7906.
Do you have to
So,
write in?
hmm,
Do you have to do, in the exam? Do you have to write down
write down what?
the formula?
The formula, no need, not necessary. I mean, but you need to write this. This must be shown. Yeah. And
Yeah.
of course, the final answer. If you don't write the formula, it's understood because, well, you must remember the exam is 3 hours and you have seen or covered all the other topics already. You know how much writing you have to do as compared to the first semester maths that you've done in discrete maths. This time, this semester, the maths is a bit, you know, a lot of writing, not like discrete maths, very clear cut. Yeah. But I feel personally here, even though it's a lot of writing, it's much more easier to know the logic of it as compared to the discrete math. Some, it depends on the students which one um, you're comfortable with. But in order to answer your question, Calvin, if you do not write the formula, it's okay. But I need you to write this, of course. Yeah. And the answer is 0.7906. Okay, Noel. So do be careful about that, especially during the final exam. Double check your answer. Make sure you didn't miss out anything. And of course, the value must be between, I mean, the answer must be between -1 to 1 only. If you get, accidentally you get a value that is more than that, more than one or less than -1, your calculation is a bit is not correct. Yeah. And Noel, your answer, the first one, 0.0125, that one should already give you an indication. Yeah. Because that value is a bit um, not acceptable. It's either very high, not very high. It's either high positive or uh, high negative. Normally the question would ask, yeah, or sometimes in within this range, like 0.6 or 0.8 within the range. So if you get an answer that is almost zero, it's quite impossible, right? So what is the comment? Our answer is 0.7906. The comment should be R indicates there is a high positive linear correlation between X and Y. Yeah. So I see Noel's answer and Calvin. Did you manage to calculate it, Farah? Farah? Okay, okay, good. Right. So here, once we know how to use the formula, the next part is coefficient of determination, which is the R squared. Yeah. Coefficient of determination is simply using the value of the R that we obtained just now, and we just squared it. So it's defined as the square of the coefficient. What is this? What is this spelling? It's the square of the coefficient of correlation. I don't know why I spelled it very wrong there. Coefficient of correlation. And when we squared the value of the R, it tells us the percentage of the variation in dependent variable y that is explained by the variation in the given independent variable x. In other words, yeah, in a simpler explanation, what is the meaning of coefficient of determination R squared is that we want to know how many percent the effect is from X. The value of the Y, how many percent is the effect is from X. That is what it means. You see, like, remember I've used an example, age and blood pressure, and from research, yeah, it's known that as you get older, the blood pressure will become higher. So you see, your X is independent variable, your Y is dependent variable. That means age is independent, the blood pressure is the dependent variable. So when you calculate the coefficient of determination, we know that how many percent, yeah, after you calculated the R squared, is caused by your age. But it's not going to be 100%. There is a balance. So the balance is basically caused by other factors. Yeah. So let me show you in the example later on. But you see, because to calculate the coefficient of determination, R squared, we squared the value of the R. So you know, whenever when we squared the value of the R, even though you have a negative correlation coefficient, you squared it, it will become a positive. So that's why your R squared, the answer you obtain must be between 0 to 1 only. You cannot get a value less than 0 or more than the value of 1. So here, to show you an example, is it on page 6 in your notes? I'm not sure. But if your R is, say, 0.8, remember the example I gave you about age and blood pressure? That means your X is your age. Hang on, let me just write it. X is your age, and your Y is your BP, blood pressure. Okay, so when you calculate your R, you get 0.8. And then when you calculate R squared, which is the coefficient of determination, yeah, you squared the 0.8, which you get 0.64. So 0.64, when you times 100%, it will give you 64%. So 64% of the variation of the dependent variable Y is explained by the variation in the given independent variable X. That means here, class, 64% of your blood pressure is caused by age. Now, from 64%, there is a balance of 36%. The remainder 36% are unexplained or unaccounted for by X, and it could be due to other factors. So that means the increase of your blood pressure is not dependable on your age only. It's dependable 36% are other factors. It could be the stress level. What else can increase your blood pressure? It could be the level of exercise that you do. Yeah. Whether you are a smoker or not, whether you know, what type of food do you eat? Do you eat a lot of sodium, salt? So those are the other factors that could cause your blood pressure to increase. It's not only dependable on the age. And the 64% is, as calculated in the coefficient of determination, is caused by the age, of course. But the remainder 36% is from other factors. It could be the stress level, it could be this exercise, amount of exercise you do. So it's good to calculate the coefficient of determination because you'll be able to know the dependent variable, how many percent was caused from the independent variable, and therefore you know how many percent is from the other factors. So that means, class, when your R is high, Yeah, when your R is high, a high value of R, you know that the value of Y, the dependent variable, is more depending on the X, the independent variable. But when your R is small, it's a low value of R, you know that there is less relationship between the two variables, and therefore the effect on the Y may be caused by other factors, mainly by other factors. Is that clear? Any question?
No.
You understand, yeah? I hope you guys understand. Because sometimes this question can be asked. All right, so that's it, I think. So there is another example 8 here, yeah, and you can see it's almost similar to the example that we did before, because we have 1996, 1997 to 2000. So I label it as 1, 2, 3, 4, 5, and these are the units sold. I'm not using 1996 as the value of X and 1997 the next value of X because it's too big. Yeah, so I'm using or replacing it with 1, 2, 3, 4, and 5. Get the total, find xy, x squared, and y squared. So all these are the values for this example 8. We got summation xy as 212, summation x squared as 55, and summation y squared as 1266. So all this, when you put it into the formula, that will give us a negative 0.9918. So what do you tell? What do you say about this answer? It is a, can we say it's a perfect?
No.
No. It's still considered because negative 0.99, yeah? So we say it as a very high negative linear correlation between year and units sold. So you see here, I'm not writing as X and Y. I'm writing in terms of the exact variable between year and units sold. So I mentioned the year, which is the X, or the year here, and the units sold. As the year increases, the number of units sold decreases, which immediately from this data you can see already, you see the units sold is decreasing. Yeah, but when you calculate the R, you can clearly see what is the degree of correlation between the two variables. And our variables here is concerning with the year and how much is sold. So I hope you see how it is used in the business world. Yeah. As you guys will be joining a computing firm, I hope you see how it's used in terms of the product that you have. Yeah. Each year you want to know whether it's showing a good performance or not. The product, is it famous? Is it popular among the clients? And you can see from this the correlation between the year and how much it is sold per year. So it would give an indication whether you should continue with the production of the product or not. Yeah. Any question about this solution? So far, okay?
No.
Okay.
Okay. Huh? So Kelvin, okay also.
Do we need to write the unit sold there when we do the
Uh,
table?
well, because this question is given in the question, none can? Not necessary, but depends on your question. Yeah. It's best that you write, if you're concerned whether you need to write the words or not, it's best you do, what is called the legend. Earlier part, you just write X, what is it equal to, and Y, what is refers to. And then here, maybe you don't have to write this line. Yeah. do that. Yeah, write what are the legend, but if it's already specified in the question, not necessary. Basically, I wouldn't be penalizing students on that. And some more, um, the marking scheme doesn't allocate any marks to it, I believe. Yeah. Okay, so if there is no more question, the next one is called the Spearman's rank correlation coefficient. But I will cover this after our break, which you all deserve. Can we come back at 5 minutes? Yes.
Okay.
5 minutes. Okay, so I'll see you
Okay.
guys in a bit. Yeah, 5 minutes. Okay, hello, welcome back.
Hello.
Okay, so now we're going to continue with the next part, which is the Spearman's rank correlation coefficient, and it's labeled as RS. Yeah, you can see it's labeled as RS. Um, it's the same as what we've done just now. It's a long formula. The purpose is the same, to find correlation coefficient, meaning we'll be able to know what is the degree of relationship between the two variables. But the Spearman's rank correlation coefficient is a different method. Yeah, the purpose is the same, but it's a different method. And the difference is that, just like what the word you see here, rank, it means when we calculate the Spearman, it is based on the ranking of the two data, meaning we rank X and then we rank Y. And the thing is, when we do Spearman, it is only an approximation to the product moment correlation coefficient R. The one that we calculated just now, earlier, is called product moment correlation coefficient R. And now for Spearman, we call it as correlation coefficient RS. Okay. And it's only an approximation. And because we're doing ranking, we're not using the actual value of the X and the Y. It is therefore possible to be applied to qualitative kind of data. That means your data is rank, so you don't need exact value. Yeah. And when you do the ranking, we do it in ascending order, meaning from the smallest value and rank to the biggest value of the data. Okay. So here there are some procedures that you need to remember in order to do the Spearman's rank correlation coefficient. Step number one is to do the ranking on the X values, and we label it as R1. Then secondly, we rank the Y values, which we label it as R2. Oh dear, I dropped something. Yeah. And then R3, sorry, step 3 is that for each pair of the rank, we need to calculate d squared, which involve R1 minus R2, you squared it. And when you do that, R1 minus R2, and you square it, that will give us the d squared. And once you get the d squared, you sum all the d squared, get the total of it. And once you get the total of it, then you put it into the formula as stated here in step 4, of which the formula is RS, the rank, Spearman's rank correlation coefficient, is equal to 1 minus, in brackets, 6 times summation d squared, and divide by n, in brackets, n squared minus 1. And of course, the value of your RS is between -1 to 1 as well, just like the correlation coefficient value, possible values. So these are the steps that we're going to follow. Okay. Uh, it may be, looking a lot of steps, but it's not difficult to follow or to do, just like what I'm going to show you next. So this is an example. This data has already been ranked. What do I mean as already been ranked? You can see the numbers here. The smallest is 1 for X only. Yeah? You look at X only. The smallest is 1, then number 2, then number 3, number 4. So we don't have to do any kind of ranking here anymore because it's already ranked. Yeah. So step number 1 is to find the R1, right? So you look at x, it would give us the same thing, because you see number 1 is here, and then number 2, it's already ranked. Same thing with y.
Miss,
Yeah,
ranking means what?
rank means you arrange it from the smallest to the biggest. Like, you see, this is your x, right? So you rank, okay, this is number 1. Meaning you, because this data, it's already arranged, not, maybe I rephrase my words. It's already from number 1 to number 10. So we don't have to do any ranking for this example. But the word ranking means rank. Rank means you give position to the numbers. So if you look at these numbers from 1 to 10, obviously you would rank, because remember, we do our ranking from the ascending order. We would rank this as number 1, the smallest. Then the next biggest, this would be number 2, because that's number 2. And this would be number 3, number 4, and number 5. And we continue.
Oh, I get it.
Yeah, like we arrange it from the smallest to the biggest. But in this case, the numbers are already in the form of 1, 2, 3, 4, 5 until 10. So that's why the answer, there's no change to it. Is that clear, everyone?
So that means the x can be other value lang.
Of course,
100.
the x, yeah, the x is depending on what the question is given to you. But of course, in this example, it's already ranked. So if it's not in the form of 1 to 10, of course, you have to find what is the smallest, what is the next biggest value. Yeah? I will show that in the next example. But this one, because you see, especially the y, to find R2, you look at it, you know which one is number 1, number 2, number 3, number 4, number 5, which is the same. Yes?
Miss, if the y like got two equal number,
That one I'll show to you in the next example. Yeah, that's a good question. I'll show it to you in the next example. But this one is just showing you that it has been ranked. I would focus on the D. So once we got the R1 and R2, which is the same, then the D is you minus R1 minus R2. So here 4 minus 6, you get negative 2, right? Yeah. So these are all the values. 9 minus 10, you get negative 1. 2 minus 2, you get 0. 5 minus 8, you get negative 3, and continue on. Once you get the D, then you get the D squared. So depending on what you got your D, you just square it. Like negative 2, if you squared it, it will definitely become a positive. So this is what I observed. Another common mistakes by student, when they put here negative 2 and they squared it, they put negative 4 as well. So that's a common mistake. So do remember, when you have negative 2, when you squared it, it will become a positive value. Yeah. So once you got this, you total all this value, sum it all up, and that should give you 42. Yeah. You calculate 4 plus 1 plus 0 plus 9 plus 4 plus 1 plus 1 plus 9 plus 9 plus 4, you get the total of d squared is 42. So that means it's settled. This is step number 1. This is step number 2. And this is step number 3, which we got the total of the d squared. So step number 4 is just putting the values into the formula. This is the formula. So just put summation d squared, which we got it as 42. The 6 is in the formula, so we don't go and change that. Take note the value of 1 is separated from all this. So 1 minus 6 times 42 over our n is 10, and then 10 to the power 2 minus 1. Now, if you recall, n is this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows. So that's why our n here is 10 as well. Is that clear? So when you calculate this, the value you get is 0.7455. Yeah, double check the answer. Use your calculator, yeah, to check that you should get 0.7455. And of course, the comment is the Spearman's coefficient of rank correlation for the data is 0.7455, is indicating to us that there is a high degree of association between rankings of X and Y. Any question, anybody?
No.
Okay. So I hope you understand how to use the formula, how to do the steps, ranking number 1, R1, ranking number 2, R2, find the D squared, and then put it into the formula. And you can immediately get what is your degree of correlation. So if you compare with the correlation coefficient, the one we did earlier, and this one, the Spearman, which one do you think is easier?
I think this one.
Yes, I would agree. This one is easier because you don't have to spend time finding the summation of xy. You know, you need to multiply xy, x squared, y squared, and find all the total and put in the long formula. This one, you just do the ranking and it's much easier and much more faster. However, class, in the exam, read the question carefully. Which method does it ask you to use? Whether to use the correlation coefficient or to use the Spearman ranking correlation coefficient. As long as you see the words rank, R-A-N-K, yeah, you must um, you must make sure that you do as specified. Yeah, if the question asks you to do ranking and then you do product moment correlation coefficient, you only get marks for the final answer because you didn't answer according to the question. Okay, so that one you need to be careful. The next example, I hope everyone clear about this already. Yeah, the next example, as you can see, it has not been ranked. All the numbers are, you know, has not been ranked as which one is number 1, which one is number 2. And if you just look at the details, the numbers that you have here, it's very messy, isn't it? So we need to do the ranking. Which one do you think is number 1 for R1?
1.07.
Yes, that should be number 1. The data has not been ranked. So you can see 1.07 is number 1. The next bigger value is 1.22. That's number 2. The next one is 1.46. That's number 3, followed by 1.47, 1.68, and then 1.71 and 1.97 as 1.95 as number 7, 3.18 as number 8, and 6.46 as number 9, and lastly 13.37 as number 10. So you see now this example 10 compared to example 9, now we have to do the ranking. Just now we don't have to do, there's no changes because the x already in the form of 1 to 10. But here you have to identify which one is number 1. Yeah. So same thing for the y. We need to find R2. So which one is number 1?
2.66.
2.66.
Exactly. So number 2,
3 3.81.
correct. Yeah. So you just go ahead with that. Now you have to be careful with very, very almost the same values like this. So be careful about that. That's my advice. So if you do the ranking, you have all this. I hope you get the same. And of course, the next part is to find the D, meaning 5 minus 3, 5 minus 2, you get a 3, and then square it. 3 minus 3, you should get a 0. So of course, that would be a 0 as well. So you'll notice that these would be all the values. And remember, whenever you have negative, if you square it, it will be positive. So you get all this value of which when you total it is equal to 26. Do you agree?
Okay.
Oh, yeah.
Yeah, it's the same, right? So what you do next is just to put it into the formula. And what do you get?
Uh, 0.1576.
Mhm. No, Noel, what was the
Oh, I
mistake?
forgot to -1.
Ah, you didn't find -1. Yeah, so be careful about that. So you should get 0.8424. And this, of course, is your interpretation. The Spearman's coefficient of rank correlation of the data is 0.8424, which indicate to us a very high degree of association between high rates and high rents, because this question is about high rates and high rents. Yeah. So this is how we get the answer. Any question
Can
for
go,
me?
can
Sorry?
go to previous slide again, the table.
Can. Yeah. So this
Uh,
is
oh, never mind. Because I was wondering why I got 0 today.
yeah. So this is your working for your R1, R2, and the D squared, and put it into the formula. And this is what you should get, the comment and all. Any question? Anyone else has any other question?
No, not for me.
Okay. Now this is because remember the first one, it was already ranked. The second one is you need to do the ranking. This is the one that we did. We have to do the ranking. Now the third one that I'm going to show you is to answer what Noel has asked just now. What if the numbers, they are the same? So you see here, this is an example. So I really hope all three of you pay attention how it is obtained. Now you see, we have salesman here, which the values of the salesman 1 to 8 is just to indicate the position of it. So we have number 1 to number 8, and basically the salesman, the cells for each one of them are shown. But you can see immediately that there are some numbers that are the same, like number 20, there are 3. And the value 35, there are 2. So how do we do the ranking for this case? So of course, number 1, you know already which one is number 1. I mean, which one do we rank as number 1 based on the sales?
The 10.
10 kah?
Position 8, isn't it? Yeah, which is correct, 10. So that one we put 1 lah. That is no problem. Now, what is the next bigger value?
20.
Yeah, but there are 3 of them, isn't it? So these 3 numbers at position number 1, position number 4, and position number 7. And by right, the next number should be number 2, isn't it? But the number 2, there are 3 that is the same. So that means position number 2, number 3, and number 4. Because 3 numbers, they are the same. So all these 3 numbers, which is the same numbers, number 1, number 4, and number 7. I'm talking about number 1, number 4, and number 7, is supposed to be position number 2. But because there are 3 numbers, therefore, it's supposed to be position number 2, number 3, and number 4. So all this, we plus position 2, 3, and 4, because number 1 is already taken, yeah? So because 3 20s are the same, that's position 2, position 3, and position 4. You plus all the position and divide by 3. Why divide by 3? Because 3 position, yeah, 2, 3, and 4. And when you calculate this, we have 2 plus 3 plus 4 is 9 divided by 3 is equal to 3. And that is what we write here. We write each one here as number 3. Do you understand? So, was it clear?
So if the number result is got decimal, so just put it like 3.5.
If yeah, yeah, just put it as decimal. Like when you calculate this gun, you get 3.5. So just put 3.5 plus. Yeah. So if we already taken position 1, 2, 3, and 4, the next position should be number 5. Yes or no? Which one is number 5?
Position 3.
Huh?
I mean
Oh,
the 25.
yeah, 25. So then we already got position number 5. The next is position 6. But position 6 is 35. There are 2 35. That should be number 6 and number 7. But because they have 2 that is 35, that would be 6 and 7. And when you plus them, 6 plus 7 and divide by 2, because there are 2 numbers, you get 6.5. And that is what you put there, 6.5. And since you already take position 6, 7, therefore position 8 is here. Just write like that. Is that clear?
Oh yeah.
Okay. So I hope that answer your question earlier, Noel. You asked pretty much advanced. Yeah. So this is how we solve it. Yeah. So you have to make sure you find the average of the same position. Okay. So I hope it's clear. The rest, any question? Like Farah and Calvin?
No.
Nope.
No. How about you, Calvin? Okay.
Yeah.
Okay. So here, um, oh, my bad. I already put the answer in. I should have done the animation without the answer, but these are the answer. Yeah, for example, 11. And you can see for X, 19 is the first position. And then there's no number 2 because the next value is 30, right? And we have 1, 2, 3, and 4. That means it's position 2 plus 3 plus 4 plus 5. And all that divide by 4. Yeah. And when you calculate this, you get 14 over 4. And that's why you get 3.5. And that's why you get 3.5 here, 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 and here. Yeah? Any question?
No.
Okay. So once you got all this, you calculate the D. That should give you, calculate the D squared as well. That should give you 127. And of course, you just have to put it into the formula. And that would tell us that we get 0.5559. And you can see the comment here. We are using the word some. There is some positive correlation between vehicles owned and numbers of road deaths, but the relationship is not strong. Yeah, there is some positive correlation, but not so strong because it's about 0.5559 only. Any question, class?
In the exam, we have to write down all the tables. So.
Oh yes, you have to. But of course, in exam, the value of numbers, like here you can see there's 10. Is that 1, 2? Yeah, about 10, I think. Is it 10 or 12? 12.
If we miss, and then we miss one number and everything wrong.
Exactly.
You got
Yeah.
marks.
No, because if you make a mistake here, can say you do the ranking incorrectly, you remember I mentioned about no double penalty. Of course, your marks will be reduced, not much reduced, will be reduced. But of course, we mark not double penalty. Like if you make a mistake in the calculation here, the R and the R1, I again will check the table whether you do give me the D correctly counted or not. That is why you need to show the table. So in case there is careless mistake, yeah. Some students, they didn't even do the table. They just give me the D squared. Fortunately for that student, the answer is correct. So with that, of course, the working is all, the answer is correct. Yeah. But remember the marking scheme requires you to show the R1 and the R2 because the marks is allocated based on R1 and R2. I mean, it must be shown. So if you did not draw the table, then you lose the marks for R1 and R2, and normally that would be about 2 marks only. Yeah. But of course, you want that 2 marks. That is very important if you want A or B, A or A minus. Yeah, it's a very big difference. Yeah, because our A is very high. Certain institution, the A is like 70, you can get A already. But certain institution, I know you must get 85, then you get A. But for us, 75 is A minus, 80 is A. That's a solid A. And your, what do you call that? The grade point, yeah, is again, is a difference of 4.0 or 3.67 if you really count in that sense. Well, anyhow, yeah, it would be best to show the table, but like I said, here we have 12 rows. It's impossible in exam, they would ask you for 12 rows to do the ranking. I bet between 5 to 10 on Leila, 5 to 10. If until 12 too many, the question will not be too long like that. Yeah. Any other question? That was a good question, Kelvin.
No.
Okay. So this is another example. Can you do the ranking for me? I already did the D squared, so you can check it out. Yeah. So can you do the R1 and the R2?
Uh,
Or done already?
okay.
Okay.
Okay. Try do this and we compare our answer. You can check based on the answer you get whether it's similar to the D squared here. Have you finished?
Oh, yeah.
Got it already? Did you get, what is your D squared?
Oh, the summation. Oh, haven't calculated.
Oh, okay. Never mind. Let us check out the answer. So this should be your R1. Any problems? Everybody get the same? Yes. Did you try?
Yeah.
Okay, good. This
Oh, yeah.
is your R2. And your answer, it should correspond to the D squared, which is already provided. And, oops, sorry. And then the total of D squared should be 44.5, of which you put it into the formula, and that should give you 0.7303. And this is considered as a high positive correlation between X and Y. Oops, sorry, too fast. Yeah. So that's it. Yeah. This is how we do the Spearman. And just to share with you guys, this is a popular area, especially the correlation, the R and the RS. Some question they would ask you to do both, meaning find the correlation coefficient, the R, and also to find the RS. So it depends on what the question asks. So read the question carefully, and then make sure you answer according to the question, not because what you know. Yeah, answer according to the question. Which method does it ask you to do? But if the question asks you to do both, then of course you have to do both. Yeah. So did you get the same answer? I hope you did.
Yeah.
Hello, any? No problem, yeah. So if there's no problem, I'm just going to look at the comparison between R and RS. Basically, the R, which is called the product moment coefficient, is the standard method to measure correlation, meaning this is the standard method and international method that is accepted worldwide. And most of the time, we use the formula R, yeah, to calculate the product moment coefficient. Most research paper, they would use R to calculate the degree of correlation between two variables as compared to RS, okay, the Spearman. However, when we're using the product moment correlation coefficient, your data must be numeric, meaning the data must be in numbers. So you must have the data basically, as compared to the RS, which is the Spearman rank coefficient. It is only an approximation to the R. It's not, how do you say, um, it's not reliable answer because it's only an approximation. Because you see, we are doing the ranking, we are not using the actual value of the data, so it's less reliable in a sense. And most research paper do not use the Spearman. Yeah. Of course, as what you see in terms of calculation, it is easier to use with less calculation, and the data can be non-numeric. That's the good thing about it, because you only did the ranking. You don't really look at what the value is. So Spearman is a good method to use when you do not have numerical data. Yeah, so these are the two comparison between the product moment correlation coefficient and Spearman's rank coefficient. Yeah, so I think that's it. We finished the syllabus class. Yeah, so here let me conclude therefore the recording. So we finished the syllabus already. Yeah. Um, we still have another 2 weeks. So, like I said, we're going to do the past year. I will tell you which past year I want you to do. I will share it either in WhatsApp or in the Google Classroom. And then I hope you guys do the questions so that we can discuss how to solve the question. I will discuss with you the solution, of course. I mean, depends whether it's going to be very accurately discussed or not. I'll talk about that further. But tomorrow for our tutorial, hang on a class, let me get the file. I don't have the file. Oh, for tomorrow, we're going to discuss tutorial 9, questions 3, 6, and 7 tomorrow. Tutorial 9, question 3, 6, and 7 for tomorrow, 1 p.m. Okay? Hello?
Oh yeah, miss. The
Hmm?
the slide just now. What
Oh,
does
you want,
non-numeric?
you want to see that one? Huh? Hang on, let me show it again. This one. You meant
Oh
this
yeah.
one. Wait,
Uh,
this one.
what is non-numerical?
Yeah. Spearman is non-numeric. Meaning, what is it? It meaning you can use Spearman for data that is non-numeric because you only do the classification, meaning you can say, let's say we're talking about imported cars. So you can say, all right, number 1 is BMW, for example. Number 2 is Mercedes, for example. Number 3 is, say, what are the cars? Well, anyhow, you can do the ranking. There is no value allocated to it, but based on your own personal experience, you do the ranking like that. So it's non-numeric law. We still put like number 1, number 2, and number 3, but it's not using the actual value of the data as compared to the product moment correlation coefficient. This one we use the actual value and put it into the formula. But the Spearman's, no, we can have data that is non-numeric and do the ranking.
But in exam or I mean, is there any non-numeric data?
None, none.
Oh,
Yeah.
oh,
If
oh.
if we're talking about exam, of course the exam will be numerical, but you see, even though the data is numerical, the question can still ask you to do a Spearman method because you do the ranking. Yeah. All right.
Okay.
Okay, so do not forget, what was it? Do not forget the tutorial that I asked you to do. Which one was it? I said tutorial 9, question 3, question 6, and question 7 for tomorrow discussion. It would be best if you can do the question first, because it's easier for you to understand for the when I explain. It's basically covering what we've done today. Yeah, that is correct, Noel. Tutorial 9, question 3, 6, and 7. Just 3 questions for tomorrow, and then next week I will ask you to do the past year, and the next 2 weeks is just for revision, basically. Yeah, and it's not recorded, so I would advise you to join the session. Yeah, okay. So I think that's all for today. It's 10:50. Yeah, that's all for today. Any question, by the way, before we leave or end the day?
No, for me.
No.
Uh,
Huh? All right, I think that's all. Farah, you already submit your assignment
No, I'll submit on
by
11.
yeah.
Yeah, before 1 lah.
Okay, all right. All right, thank you everyone. I think that's all for today. See you
okay.
tomorrow. Bye.
Okay,
Thank you, miss.
bye.
Bye bye.